Okay, reporting category 2, interpreting unit rate. Unit rate is how much for one. All right, you'll see the words how much for, or how much per, or how much for every. Okay, so just an example is, hey, you go to the store, you see 24 bottles of water for $5.50. All right, so let me kind of write that down right here. So 24 bottles of water for $12.80. All right? Sorry, 24 bottles of water for $12.80. You know, teacher will ask you, what's the unit rate? Or how much per bottle? How much is the unit rate? How much per bottle? How much for one bottle? All right, that's what unit rate is. How much for one? All right, and it comes in handy when you're trying to go shopping. Well, what's cheaper, to buy 24 bottles at $12.80 or 36 bottles at $14.50? All right, so what you do is you're going to do what's called divide y by x, or, you know, if you're dealing with money and amount, it's the money divided by the amount. Okay, so let's see. $12.80 for 24 bottles. $12.80 divided by 24 bottles. 53 cents. 0.5333. Right, that's the answer you get. But like I told you earlier, we're only concerned with the first two numbers after the decimal. So I'm claiming that it's 53 cents per bottle. Well, let's check. You can go the other way around now. I'm claiming it's 53 cents for one bottle, times I'm buying 24 bottles. I should get $12.80. Only 53 times 24. Yikes. $12.72. Okay, well that's because I didn't use all the threes. All right. It's going to get you in the general vicinity. All right. I'm glad this came up. All right, because see, I just typed in 0.53 when there in fact is a bunch of other threes. Well, that comes into play a little bit by like a fraction off. So let me try it this way. 0.533 times 24. Okay, there you go. All right, but you know what? We don't deal with money into the gazillions. All right, we're only concerned with the first two numbers, really. All right, if I asked you, hey, what's the unit price for 24 bottles going at $12.80, I would accept the answer 53 cents, and so would the STAR test. Okay, so let's talk about this right here. They're going to give you some graphs. All right. The graph below shows the amount of money in dollars Connie has in her savings account over time. Which of the following is a true statement about this situation? All right, so this is where, you know, y divided by x is going to come into play. Because this is going to give us our unit rate. All right. So let's take, I'm going to make a little graph. All right, I'm going to pick an x and a y. I'm going to make a couple different. Okay, so I'm going to start with 2 hours. I'm not going to try to guess like halfway in between. Like it says 1 month, and there's my dot right about there. It corresponds with somewhere in between 50 and 100. So I guess I would estimate what comes between 50 and 100. I guess I would say 75. All right, but let's go with what we exactly have. Right here, I have a point. Right here, my point is at an intersection, and right there. Okay, so look, months. Remember, this is my x. It corresponds with the 2. Okay, the 2 corresponds with the 150 on the y line. So let's see. Let's see if I guessed in 1 month I do I earned $75, or Connie put $75 in her account. That was what I was kind of claiming. Let's see if that's true. So I'm going to do y divided by x. Let's do 150 divided by 2. You type it in your calculator, and yes, you get 75. So it looks like in 1 month, Connie does have $75 in her account. All right. Let's just double check to be sure. In 4 months, Connie has 300. Okay. 300y divided by 4, which is my x, 75. So 300 divided by 4 is 75. And just for kicks, 6 and 450. That goes to show you can pick any line on the graph. 50 divided by 6. I type it in my calculator and I get 75. All right. So look at our answer choices. Connie saves $1 every 75 months. 75 months isn't even listed on here, and $1 would be down there. That's not going to happen. Connie saves $75 every month. That's what we're saying. Remember, every month, per month. Connie saves $75 per month. That's my unit rate. Connie saves $500 every month. Here's $500, and that corresponds with about 6.5 months. All right, 150. Does she save 150 a month? No, we figured out that 150 a month, or $150 was in 2 months. All right, so that's incorrect. Okay. Let me zoom in, and why don't you see if you can do this one real quick, if you're playing at home. All right, let me get it in there. Oops. Straighten it out. See what you can come up with right there. Alright, it might be hard to see at home. Alright, just go ahead and pause it, and then we'll see what you got. See if you were right. Okay, so right off the bat, it says, which of the following is a true statement about the situation? The rain fell at a rate of 1 inch every 2.5 hours. So we had a graph. Time is my x value. Rainfall is my y value. So in 1 hour, it looks like it's just above whatever that line is. And let's talk about that for a second. 0, what comes between 0 and 4? 2. So looks like they're counting by 2s. In fact, they are counting by 2s. So 0, 2, 4, 6, 8, 10, 12, and so on. So in 1 hour, it looks like it's just above 2. So like in 1 hour, I would say about 3 inches of rain. Okay, well, let's take a look. Let's go with what we know. I'm going to pick 1 point right there. 4 hours, which is my time on the X line. 4 hours is equivalent with 10 inches of rain. Okay? Remember, we're going to do y divided by x. Type it in the calculator. 10. Don't do 4 divided by 10. Follow closely. Y divided by x. A lot of kids in the same way. It's first, so I put that first. No, it's got to be y divided by x. So 10 divided by 4 is 2.5. So, in 1 hour, it's going to rain 2.5 inches. All right, don't be confused. Look at D. The rain fell at 2.5 inches every hour. Okay? In 1 hour, the rain did fall in 2.5 inches. In 1 hour, the rain fell at a rate of 2.5 inches. This one is the tricky one. 1 inch every 2.5 hours. All right, let's say we get the answer 2.5. Don't get DNA confused. Look at your graph. In 2.5 hours, which is about right here, it looks like it rains about 6 inches. Okay, so this one's backward. All right, so just be careful. Last one, let's look at this one. I need to zoom out just for a second. Okay, a snowstorm occurs in Chicago. The graph below shows the constant rate of change of the snow level on a city street. Make my table. I have time in hours, snowfall in inches. Let's label X and Y. Let's pick a point. Two hours, it snows 4 inches. Let's do Y divided by X, which is 4 divided by 2, which gives me 2. All right, that's my unit rate. In 1 hour, it snows 2 inches. All right, my unit rate is 2 inches every hour. Let's look at A. 1 inch every 2 hours. Okay, no. All right. The snow is falling at a rate of 2 inches every hour. Okay? 1 hour, 2 inches. And even look at the graph. Right there. I could have picked that point right from the beginning. I can tell that I'm counting by twos. In 1 hour, it snows 2 inches. The snow is falling at a rate of 2 inches every hour. 2 inches per hour. My unit rate is 2 inches of snow in 1 hour.